Welcome to Homework Lib.
Hi. The first thing that we need to do is to find the ppms of Cl- that we have in the solution. So we're told that we dissolved 9.1748 grams of sodium chloride in a 500 milliliter flask, which corresponds to 0.5 liters. Now let's remember that ppms correspond to milligram per liter. So first of all, we need to convert these grams of sodium chloride into moles of sodium chloride. So we know that the molar mass is 58.44 grams per each mole sodium chloride. Next up, we're going to employ the conversion factor that 1 mole of sodium chloride is going to produce 1 mole of Cl minus. Now 1 mole of Cl minus corresponds to 35.5 or 35.45 grams, just to keep it as accurate as possible. And we know that we want milligrams on top, so in 1 gram, we're going to have 1000 milligrams. After doing all of this, the result is going to be in milligrams per liter and gives us 11,130.96. So this solution corresponds to a 1 to this in ppms. So for the next part of the problem, what we are going to do is we're going to employ a table that tells us the concentration in ppms versus the potential in millivolts that we're measuring. So in this case, the potential corresponds to 160, 94, and 40. So if you plot these results, what you're going to see is that essentially this is not a linear plot, and this is because this potential corresponds actually to applying Nernst's law. So for an ISE electrode, so that is an ion selective electrode for chlorine, the potential is given by E0 plus a slope times the logarithm of the concentration. So what you actually need to plot is logarithm of concentration versus the potential in millivolts. So the logarithm of the concentration is 2.3026 if you round it up, 4.6052, and 6.9077. Actually 78. Okay. And the potential in millivolts, it's going to be the same, 160, 94, and 40. So if you plot this, you're going to see that you will have now a line, and you can do a linear regression. And the value for the linear regression corresponds to y equals to minus 26.058. This is the slope times x, that is going to be the logarithm of the concentration, plus 218. Perfect. And just in the case that you need to provide this result, the value for r squared is equal to 0.9967. Okay, so now with the information of the linear plot, we're told that a sample of unknown salted water presented a potential equal to 132 millivolts. So this has an unknown concentration. So what we're going to do is plug these values. This is going to be your y into our equation and solve for x. So 132 is going to be equal to minus 26.058 times x, and x is the logarithm of the concentration, plus 218. So the logarithm of the concentration will be equal to 132 minus 218 divided by minus 26.058, giving us, so the result of this operation is equal to 3.3. So now the concentration, we need to take the exponential of this result. So, this is a box. The final concentration will be 27.12 ppms. And this is going to be our final answer. Just to verify, we knew from the beginning that the result was in between 10 and 100 ppms, and the result is consistent with that. So that would be all. Thank you very much.